one of them is able to make cellulose like this. So maybe it could be quite hard to see, but you can find cellulose fiber is extruded from this bacterium. Okay, and what is really interesting is, as you've seen, so many types of the organisms making cellulose, but in any cases, they are making fibers anyway, as I explained first. So each of them, depending on the species, the size of the microfiber is quite different. Then the number of the chain is quite different depending on the species, But what is common between them is many cellulose chains are packed together into one microfiber. For making the microfiber is so excellent property, I think. Okay. Then, so this means that if I want to study cellulose biosynthesis, I have many choices. Maybe I can select plant, I can select algae, I can select tunicate, I can select bacterium. But at the moment, we are selecting this one, bacterium, because it's so easy to use. Because maybe if you have X-ray, because it's really easy to maintain in the laboratory, and you don't have to care about that. Just we can put in the freezer, and then they can survive the freezer, and then you can take out when you need. So it's so simple to handle. Then that's why we're using this one mainly. Okay. Okay. So as I explained, cellulose microfiber is quite important. It's playing a quite important role for showing excellent property of cellulose itself. We have to think about, it is so difficult to make cellulose into microfiber. It can be spontaneous because structure of cellulose, as I shown. Because the structure of the cellulose is better one as I explained like this, and it's the shape of the structure cellulose chain is so straight and rigid. So it's quite reasonable to think about, okay, the microfiber formation by assembling this such straight chain and rigid chain into one fiber is spontaneous. It can be automatically done, but actually it's not. And we have tried many several experiments. And for example, here one of the examples here. So here, so this is showing the cellulose synthesis in vitro in test tube. So what we did here is from this bacterium we take out the enzyme that is responsible for production of cellulose. And then you can add the substrate or you can add factors which is required for cellulose production into the test tube. Then it becomes, first it was clear, but as you see here, it becomes carbon, it becomes white during the process of synthesis. Then if you analyze this product the product in this tube by electron microscope, it becomes like this. So it's just aggregation. It never looks like microfiber. And so this is another analysis which is called electron diffraction. And I don't explain detail, but what we can understand from here is the cellulose packing here is quite different from the native one. But of course, you can easily understand the shape, the morphology of the cellulose is never looks like the native microfiber cellulose. So it means that in this way, we cannot reproduce the cellulose synthesizing activity, the native cellulose synthesizing activity. Cellulose is cellulose, which was evidenced by electron diffraction or X-ray diffraction or infrared spectroscopy. But anyway, we cannot have the natural fiber here in this artificial synthesis. That's the point. Okay. So at the time, why cellulose 2? Cellulose 2 means this. I'm sorry. Cellulose 2 is the name of one of the structure which is non-native form of cellulose, and why cellulose does not become cellulose microfiber, and this is what I saw when we got this kind of data. Okay, and at the time we saw that the enzyme in the test tube was dancing in the solution freely. Then they cannot control, and then they are, how can I say, they are crystallized, they are packed together without control. Then that's why it could be the reason why we cannot make such a nice cellulose fiber. Then what is done in the native case? And in the native case, cellulose enzyme is embedded in the cell membrane of lipid bilayer. So this is a big difference. And then maybe we have to do this kind of thing if you want to make cellulose into a microfiber. That's what I saw. So like this is a schematic diagram, and then if you can set your cellulose synthesis in the liquid bilayer together with some other factors which is required, it should be possible to reproduce cellulose, native cellulose synthesizing activity. So namely, which transfer, which is done, which has to be done here. So the substrate is here. I mean, the starting material of cellulose biosynthesis in the cell is this molecule, which is called UDP glucose, and this glucose form is transferred to the tail of the cellulose chain, which is in elongation in the synthesis. So this is the process of polymerization. But after the polymerization, each cellulose chain has to be packed into one microfiber. So that is the last final third step of cellulose biosynthesis. So maybe by locating the cellulose synthesis enzyme into the liquid bilayer, it should be possible to reconstitute these three activities. That's what I thought. Then we determined to take this approach, which is a reconstitution approach. So the idea is so simple. If you want to reproduce some biological activity, just you can assemble what is required for that activity. It's so simple. So let me show two examples of that reconstitution approach. One is this is coming from the Nature paper in this year. So yeah, this is reconstituting one biological activity, which is replication of the DNA, which is really important. But anyway, what I have to point out is that they just added 42 polypeptide in a correct sequence into one test tube. Then they made such a complicated biological function. So this is one of the examples. So they actually prepared 42 different polypeptide and they just added into one tube in a correct order. So this is really tough work, I think. And the second example is iPS cell induced pluripotent stem cell. So this is quite hot topics in the medical science. And what is done here is just they are adding what is necessary to the somatic cell, which cannot be reprogrammed usually. But by introducing 3 or 4 factors which could be required for making them the pluripotent cell, it is possible to induce the pluripotency to the somatic cell. So this is the idea of iPS cell. So by adding something necessary, maybe you can convert something to what you want. So the idea is so simple. Then, while in cellulose biosynthesis, why have to do that? We have to do that. Then, what is required for cellulose biosynthesis that we have to think about? Then, actually, nowadays in 2013, there is one big report about the structure of cellulose synthesis and the related papers, and those kind of papers from the group of United States reported that. Anyway, A protein, B protein, and a small molecule which is called CDIGMP. This is the molecular structure. These 3 factors are necessary. Then, just by adding these 3 factors into for example, test tube, it could be possible to reproduce cellulose synthesis activity. So idea is so simple, but nobody has done it. Then we decided to do that, and the same that, so this is the schematic. This is the schematic diagram. What I did, and this is coming from the textbook of biology, and it's so simple idea. If you want to reproduce one of the biological activity, just you can introduce the DNA. So in my case, it was cellulose synthesis gene, that is DNA, and then you can introduce this DNA into E. coli cells. Well, it can be any cell, but in our case, it was E. coli cell, and we introduced cellulose synthesis E. coli cell, and of course, by introducing this gene once is converted to the protein, which is cellulose synthesis in this case. Then cellulose synthesis is, of course, the enzyme to produce cellulose, and if they can work correctly, of course, this E. coli cell can produce cellulose. We can convert E. coli cell to like that. Okay. So this is the schematic diagram. What I did here, yeah, let me skip here because this is just a little bit extra time. Okay. So anyway, what I hear is just we introduced two genes into one E. coli cells. One gene is about the cellulose synthase, and the other gene is called DGC. And DGC is an enzyme to produce GMP. And let me repeat that. GMP is this small molecule. This is not protein, but this is necessary for activating cellulose synthase. After GMP binds to cellulose synthase, they can be activated to produce cellulose. Then this is also necessary. Then we want to have GMP in the cell GMP, and for doing this, we introduced another enzyme which is responsible for production of GMP. Okay, so here we just introduced two genes into one E. coli cell, and this technique itself is nothing special. Everyone can do that. It's really nothing special. So this is just a biochemical analysis for showing the expression of protein, so I can skip it. And this is again, this is evidence that GMP was produced in E. coli cell as I expected, and this is LG-mass data, and I don't describe anything, but as far as we checked, the concentration of GMP was enough for activating the cellulose synthase in E. coli. Okay, and after that, then we made a culture of E. coli cell for producing cellulose in the plasma, and then we collected cell and cellulose by segregation, and we washed the cell by strong acid treatment. And this is called AM treatment, and when cellulose is included in the sample, some white powder survives after this treatment, actually here. So like this, in the condition which is fitting the conditions required for cellulose biosynthesis, cellulose was made. Okay. Then after that, okay, this white powder is meaning that cellulose was produced correctly. Then next, we analyze what kind of structure we can find in this cellulose. I'm sorry. Now before that, so this is just a visualization for making it sure that cellulose is produced by eyes. But of course, for science, we have to quantify how much of cellulose is made by like here. So here, here we have 4 different conditions, and after these are negative conditions, but we have to check if this is truly negative or not. Okay. Then we made a quantification by using some chemical reaction, and then this is a result of that. Then let me skip in detail, but what we can understand from here is cellulose A and B protein was necessary, and GMP was necessary. And the other condition, no production or almost no production of cellulose. Okay. And okay, let me see this one better. Okay. Okay. Then we go to the analysis of the white powder we can find after washing by acid. So this is the IR spectrum, and this is the X-ray diffraction, and this is the electron diffraction, and maybe this is quite easy to understand that, okay, the product is not fiber again. And from the diffraction, electron diffraction, and from IR spectrum, and from X-ray diffraction, again, we can understand that this is not native structure of cellulose. Namely, all these data showing that cellulose is crystallized into cellulose 2. Which is non-native crystallographic structure of cellulose. We should have cellulose 1. Okay. So let me summarize here shortly. And cellulose production by recombinant cellulose synthase complex, which is cellulose synthase A and cellulose synthase B in E. coli, was confirmed by biochemical assay and structural analysis. And CSC and CSB are the minimum required subunits for cellulose synthase activity, but which has been already shown. But we just rejected it. And the GMP is required for cellulose production as well. So this is also again the re-investigation, reconfirmation of what we are believing then. Okay, then next, we are quite interested in, okay, cellulose was made, we can evidence. But where we can find cellulose? In the case of the glucose acid vector, which we use as a model, there we can find cellulose outside of the cell. Then we guess that maybe we can find cellulose outside of the E. coli cell in our case. Then this is a very simple experiment, and we make the same culture actually. we make the same culture for making the cellulose by E. coli, but in this medium, we added cellulase, which is cellulose degradation enzyme. So this one, blue bar is the cellulose production in the presence of cellulase. Then it goes down, and usually cellulase or those kind of enzymes cannot go inside to the E. coli cell. So this data means that clearly that cellulose is found outside of the cell. That's why by cellulose treatment, the production of cellulose was estimated lower than the other case. Okay. Then just we can check by the electron microscope if that is the case, and we can find that okay, cellulose was produced in the outside of the cell. So this is the right microscope and a fluorescence microscope, and here we used dye for staining the cellulose specifically, and this is as you see the blue dye, and we can find so many cocoon-like structure which is stained by calcium, which is a specific dye to cellulose. And this data is clearly showing that okay, cellulose is found outside. And in the negative condition, we cannot find such a blue cocoon-like structure. And in these three micrograph is coming from electron microscope, and this is a lower magnification, and this is a higher magnification. Okay. So, and this is the E. coli cell, and outside the E. coli cell, we can find so many fiber network right here. And this is and if you enlarge this structure like this, it looks fiber. So it was quite amazing for me because fiber structure could mean that this is a native structure of cellulose. And this is another type of electron micrograph, which is called shadowing. And yeah, as you see here again, we can find a fiber structure in a different mode of electron microscopy. But so it was so short that we can find such a fiber structure. Okay. Then, of course, we have to know that if this is truly cellulose or not. The evidence from here can show that okay, this could be fiber. This fiber is cellulose, of course. But we have to get evidence for that. Then we treated this fiber structure by cellulase again, which is degrading cellulose. Then, if this fiber structure disappeared by cellulase, this fiber structure could be cellulose structure. Okay. Then, as we expected, if you didn't treat by cellulase, still we can find a fiber structure, for example, here. And this is a higher magnification. We can find many fiber structure outside the cell. And if you treat it by cellulase, such fiber structure started to go away, right here. And if you increase after concentration of the cellulase, most of the fiber structure was gone already like that. And the last one is a negative control, and I treated with another type of protein, not cellulase, ribozyme, which is degrading the lipopolysaccharide bacteria. Anyway, this protein cannot degrade cellulose, and by such negative treatment, we can still find the fiber-like structure. So from these evidences, we concluded that this fiber structure is maybe cellulose. That's our conclusion. Okay. But here, it is. But there is one big discrepancy if this is a cellulose. Because so this is an electron micrograph which was obtained after washing by any treatment or any other chemical treatment for washing out the E. coli cell. But once you wash with these kind of treatment, we can never find the fiber-like structure of cellulose. Always we can find such a globular-like structure. But from electron diffraction, we are sure that this is cellulose. But for the native for this electron micrograph as well, from the cellulose treatment, this fiber structure was gone. Then we can conclude that this fiber structure is cellulose. But it's big strange that fiber structure, but this is really strange. What is really strange here is if this is a fiber structure, this could be native cellulose structure. But native structure cannot be converted to this such application by this treatment. I mean, this treatment is too mild, too weak. as far as we know, to convert the fiber structure to such a globular structure. So this is a big mystery for us. Then,
I'm sorry, Professor, you have 3 minutes more.
okay, thank you. Okay. So this is the enlargement of the two different structures. So this is before washing and this is after washing. And actually, if we looked at this fiber structure with higher magnification, yeah, it's fiber. But so this electron micrograph is coming from another example of cellulose, but this is coming from the plant cell wall, and this is coming from the strawberry cell wall, and which is one of the tiniest cellulose microfiber in the world. And the size of the microfiber looks quite similar, but its appearance is a bit different. In this case, this is cellulose one, native structure. And in this case, the shape of the cellulose looks quite straight, but here it's wavy structure. So I guess that maybe this is not native structure of cellulose, but it looks like fiber. Then, simply saying, this could be, one chain of cellulose. Then that's why mild treatment can convert this fiber structure to such a globular structure. That's what I thought. So anyway, there was one big mistake, but even that, we can successfully reconstitute cellulose synthesizing activity into E. coli by expressing GGL-GMP shrinkage together. Okay, but not in the native structure. Still, we have something to do for improving that. Okay, and next, then so it means that we have some missing factors for reproducing the native activity of cellulose synthase. And what are these? Okay. And one of the candidates is actually cellulose synthase are believed to compose of different polypeptide subunits, right? Like as shown here. So here and 7 proteins are included in the cellulose synthase complex, and we exclude only A and B in this case. Then what about C and B or GH3 or GH8 or CCP2? We have to express together all these proteins, and then we try some of them. Okay, but the situation is same. Even though we express some more subunits, it becomes cellulose structure. So washing, then we cannot improve anything by expressing more subunits at the moment. So yeah, and what else? So one is another kind of candidate to what that is necessary for making cellulose microfibers terminal complex. And this is the terminal complex, and which is believed to cellulose synthase complex that is observed by the electron microscope. And here, enzyme is in a cube. Enzyme is arranged beautifully in a cube like this. Okay, so maybe we have to reproduce such a nice cube of cellulose synthase complex in E. coli cell. So that is shown by electron micrograph, and that is shown as well in fluorescence optical microscope. So we have to make such a nice arrangement of cellulose synthase if we want to make cellulose microfibers. That's what we're believing at the moment. Okay. So summary. So now we can successfully reconstitute cellulose synthesis activity in E. coli. Then we are calling this system as cellulose synthesizing E. coli, and this is really useful, convenient, easy to use tool for analyzing cellulose synthesizing activity. And but at the moment, as I explained, we do not have a reconstitution of the native activity of cellulose synthase. And actually, this is a system which is lacking something. So this is really, in other words, this is really convenient to find out what is missing factors for making cellulose. Okay. Yeah. Sorry. So that's acknowledgement. So these are sorry. So these are my collaborators for this project, and so this is the part of the analysis was done in our institute, and these are the financial support for making antibody, and these are bioresources I use, and these are the funding. So thank you so much for your attention.
Okay, and now is the question sessions. If you have any questions, please raise your hand and come and mention your name and your institutions. Any questions, ladies and gentlemen? No one? One question maybe? Okay.
Thank you. My name is Wahyu from Biomaterials. Simple question. How about the strength? Have you explained? Yeah, more. Yeah.
Strength of the fiber structure.
Yes, compared to the native.
It's a really difficult task, I think, and honestly saying, I don't have any idea how we can analyze the strength of the smooth fiber, but maybe we can use AFM or atomic force microscopy or something as done by Professor Iwata in Tokyo University or those kind of guys. But yeah, it's a really good idea to know what kind of properties they have.
Any other questions, ladies and gentlemen? No? Okay, I think it's all. Thank you, Professor Imai.
Thank you very much.
And now we would like to kindly ask Professor Imai to stay in front of the podium. I'm sorry, in front of the podium.
Here, Professor. Yes.
We would like to ask Dr. Wahyu Duyanto to come forward for taking the appreciation. Thank you very much. For the next lecture, will be delivered by Professor Toshitaka Suda from Greece, entitled Study of Equatorial Fountain in the Middle and Upper Atmosphere over Indonesia with the Equator and Radar. Thank you, Professor Suda.
Thank you. I'm very delighted to give a talk on our project. We have been collaborating with FAN and the other colleagues on equatorial atmosphere science. And this slide shows a new proposal for construction of a big radar, which is called equatorial MU radar. M and U stand for the middle and upper atmosphere. This is a very famous picture. I think you have seen many times. This was taken by a Japanese lunar mission, Serene. And we can see a very beautiful planet, Earth. It covers with the ocean and the clouds. And we are enjoying a beautiful life on this planet. The question now is that how sustainable can we continue this environment? And of course, our Earth is limited in resource and also space. However, this area, atmosphere, forest, and human habitat, it is not a closed system. Of course, resource material are limited, but we are receiving energy from the sun. So main topic of this talk is the coupling process between the sun and the Earth's atmosphere. We receive solar energy in various ways, and because of that, there are many meteorological phenomena, atmospheric dynamics occur. And simultaneously, biomass grows because of solar radiation. So in the future, we need to consider how effectively we utilize the solar energy in the sustainable human. One example here is the solar power satellite. In the space, we receive solar radiation, and the electric power is transmitted on the ground by microwave. And of course, there are various ways to utilize biomass materials, energy for the chemical products. This summarizes the kind of interaction between the sun and the earth. We on the earth, we receive energy from the sun in several ways. One is, of course, the solar radiation. Sun emits the solar radiation in various ways, visible band, ultraviolet, infrared, and X-ray. And in parallel, when the big event occurred, unstable occurred, which is called coronal mass ejection, that emit high energy particle. That is also called the solar wind, and it interacts with Earth's geomagnetic field. So it not directly impinge into the Earth, but in the polar region, Arctic and Antarctic, these electric particle precipitation occurs. And outside the solar system, we receive the galactic cosmic rays. It's a very, very high energy particle. And there is some discussion, cloud formation is affected by galactic cosmic rays. And now, coupling process in the solar terrestrial system, main target is the solar energy input into the Earth, and the response of our environment, including geosphere, which is called geospace, magnetosphere, ionosphere, and atmosphere. And as I mentioned, the solar energy can mainly be divided into two parts: solar radiation and solar wind. And solar wind, of course, becomes maximum over the equator, here over Indonesia. And because of this intense solar radiation, atmospheric disturbance are generated. And they further excite various atmospheric disturbances that actually drive entire atmospheric general circulation. The other one is the electromagnetic energy associated with solar wind that converge into the polar region. More precisely, so energy particle, charged particle interact with geomagnetic field line, so it cannot encompass this field line, but the flow like this, and just enter only in polar region. And the part of the energy is propagated into mid-latitude or lower atmosphere. So in our study, we focus on two parts, equatorial region and polar region. And in my talk, we mainly discuss about the effect of solar radiation heating over the equatorial region. This is the schematic diagram of a project called the climate and weather of the Sun-Earth system. It was continued for 10 years since 2009. I was the international leader of this project in the last few years. So there are four main themes. One is the solar influence on climate. Solar variation has a long history. 11-year cycle is very famous, but 100 years or 10,000 years, very long history. So that kind of very long variation of solar irradiance, solar radiation intensity, may affect the climate. And for short-term variation, like coronal mass ejection, that directly affect the Earth's environment, especially for satellite system. Okay, the solar radiation actually directly come down to the surface, and our ground surface are heated up. Then this energy, heat energy, is redistributed up to the atmosphere. So transport of the solar heat energy from the ground to upward into the middle and upper atmosphere is very important issue. And also because of global warming, this structure of atmosphere is changing. So this upward transport of energy may be affected by global warming effect. So this is the overall scope. And so we want to observe entire high plane simultaneously. And high plane is classified because of temperature structure. Lowest one in the troposphere, up to around 10 to 15 kilometers. Temperature decrease because this is a heat source, and away from the heat source, temperature decrease. And 15 to 90 kilometers, temperature become lower because of absorption of solar radiation by ozone. This is the heating process. Then again, cooling occurs. And finally, in the ionosphere or thermosphere, other type of, except for ozone, other types of species receive solar radiation and also from the atmosphere. So this is a basic structure. And as I mentioned, that the middle atmosphere is basically range from about 10 to 100 kilometers. And the upper atmosphere is beyond 100 kilometers. And there are various phenomena occurring originated from the solar intense radiation. This is a picture of the MU radar, middle and upper atmosphere radar in Shigaraki in Japan. It was constructed in 1984. The name comes from this high range. This radar can measure entire high plane from the troposphere, middle and upper atmosphere. So this antenna system, and the diameter is about 100 meters, and each antenna element is the 3-element cross-Yagi antenna. So in total, there are around 500 Yagi antenna elements distributed in this area. And this is the first in the world that we employ the solid-state transceiver module for this system. So the antenna itself is sitting; it doesn't move. But by active phase array system, we can steer antenna freely in any direction. It's the most advanced radar system. It was designed 30 years ago, but still it's the advanced system. One example of this radar observation, normally at the meteorological office, like BMKG, a balloon is launched to measure wind above the ground. So this is a 6-hourly interval. With interval of 6 hours, 2 balloons were launched. So this is a vector showing zonal and meridian, that means the east, west, and the south, north, south in component. Nothing particular occurs. That's a weak wind system. But actually, during this period, typhoon passed over this observation site. This is the same time and height frame. The balloon sounding was done here, but black arrow is the observation by using the view radar. I mean the continuous time and height monitoring. then we found that the typhoon passed over the radar site here. So very intense and rapid variation was seen. So this radar remote sensing is characterized by a very fast and good resolution observation continuously in the entire country. Another example, by employing advanced interferometry technique, we can get a very good height and time resolution. This may look like a cloud, but this is actually an atmospheric turbulence. In a clear air atmosphere, we still have a turbulence. And we cannot see by the eye, but by the eye of radar, we can see the detailed structure. And this blow-up, so vivid mixing occurred because of turbulence. And for example, the atmospheric constituent emitted from the ground is transported and mixed by this turbulence and transported somewhere. So mixing and transport of minor constituent it is very important subject, and the turbulence affect largely of this mixing. Another example, I so far show that the wind velocity measurement by the radar, but this radar can also measure temperature. This shows the basic principle of this technique. We combine radar and the acoustic sounding system. As you know, the sound speed is related to ambient temperature. A square root of temperature is proportional to the sound speed. So we emit large sound from the ground and it propagates upward. And with the radar, we track it, then detect the propagating speed, that means the sound speed. So by combining acoustic sound speed source and the radar, we track, we get a high profile of sound speed. From that, we get the temperature profile. This is one example of combined temperature and wind velocity measurement. Arrow is again the wind velocity. In this case, the vertical and the meridional wind component. In the background, color contour indicates temperature perturbation. Warm color and the cold color show the interaction of cold front here. So this is the sorry, this is in Japanese, but I think you understand. Cold air and warm air encounter, then the front genesis occurs, and the upward motion is generated, and eventually main cloud is generated. So by comparing these two, you can clearly see interaction of cold air and warm air, and also upward air motion, and some disturbed atmospheric condition associated. This is similar to the turbulence measurement that I have shown a few slides ago, but this is the temperature perturbation. Exactly the static stability, height gradient of temperature. So from this one, we can identify, for example, the inversion radar or the temperature perturbation. This one day and this midday, the noon time, you can see a fluctuating component propagating upward. If you blow up, you can verify around the noon temperature perturbation is generated and it reaches up into the tropical. So this kind of time height structure, vivid variation can be monitored with this data. This year in May, IEEE, this is the one of the biggest research organization. I think about 500 million members on electrical engineering. IEEE awarded a milestone to the new radar Kyoto University and the manufacturer Mitsubishi Electric Company. They say that the active phase array antenna system was first employed, and it is effectively used more than 25 years. For this achievement, I should be awarded this milestone. So our system is a kind of origin of this radar plus radar technique. So we want to enhance our activity more to other applications. And one of the target is the equatorial atmosphere. I keep saying that the equator is the most important region to receive solar energy. So we continued our research in Japan at mid-latitude, but we are keen to come to Indonesia to continue and apply our technique. So again, because of solar, intense solar radiation, ground is heated up. Then this heat energy generates cumulus convection, for example. And this disturbance further generates various atmospheric waves. And these waves does not stay at the same altitude, but they can propagate upward. That means these disturbances carry energy and momentum from this side range to higher altitude. And finally, for example, producing electric ionospheric disturbance, which is called the plasma fountain. So this entire side range from the ground up to 1,000 kilometers are coupled, originated from solar radiation and disturbance and atmospheric and the electromagnetic disturbance. Oh, I forgot to mention one thing. We name this entire phenomenon as the equatorial fountain, like a fountain of energy and material. So equatorial region is important, but especially Indonesia is the most important in the world. This is the cloud distribution from the satellite. So blue region indicate the tall clouds. So over Amazon, Africa, and the maritime continent around Indonesia, you can find the blue region. And this is wide and the tall cloud exists. So it's the most active region. So we found observation site at Kitingi facing to the Indian Ocean here. And equatorial atmosphere radar was installed year 2001, similar to the view radar in Japan. But the one big difference is the output power is only 100 kilowatts. The view radar is 1 megawatt. So the 1/10 of power that reduces the height range to cover the observation. Again, I'm showing the idea of equatorial fountain. We want to cover entire height range. I'm showing some example, scientific example of this study. For example, the long-term balloon sounding in Indonesia show the correlation between the tropospheric ozone and the dipole node in Indian Ocean. So the chemical process is coupled with the dynamical process. And another thing, during dry period, during El Nino in 1997, ozone amount increased because of biomass burning. This year, again, El Nino is coming. So the biomass burning in Kalimantan and Sumatra, they affect directly the environment, but also that affect the chemical composition in the troposphere and the stratosphere represented by ozone. Equatorial atmosphere very unique. Various chemical products are emitted in the urban area, and they are once accumulated into the equatorial region because of this circulation. Then it is uplifted into higher altitude, into the middle, only over the equatorial. So this is kind of entrance for chemical products into the upper atmosphere. So this transport system we have to monitor continuously. And because of temperature over the tropical troposphere is very cool, so very cold. So the amount of water vapor content is squeezed, but still we have some puzzle that the amount of water vapor does not agree with the theoretical prediction. This is again the cloud distribution, and from this cartoon over the cloud convection we may expect the active atmospheric regeneration. And here is the analysis of satellite data of atmospheric wave activity. One-to-one correlation is very good. This is the troposphere below 10 kilometers, and this is over 20 to 30 kilometers. So the convection in the lower atmosphere directly correlate with the wave disturbance in the upper atmosphere. So this cartoon is verified with this observation. If we go to ionosphere, ionospheric disturbance is seen. Probably tomorrow, for example, Yamamoto will explain in more detail. But the plasma bubble frequently occur over the equatorial region. This affects the navigation, satellite navigation signal. So that, for example, GPS navigation may not work well when these plasma bubble occur. This one picture taken from the Peruvian radar in Peru. We are hoping to have a similar capability with radar. Then we can cover up to nearly 1,000 kilometers. And this vivid variation of plasma fountain will be observed with the new radar system. So since 2001, we continued equatorial atmosphere radar successfully, and we celebrate the 10-year anniversary at RISTEC. And next year is the 15-year anniversary. So we'll have another chance to celebrate our victory, I hope. So this is a Google map of equatorial radar site. There is kind of a table mountain with a 1 kilometer and 1 kilometer space. And the EAR is located south end of this area. The reason is we wanted to have a bigger radar like the view radar in this observation site. And we now propose to establish equatorial view radar here next to the EAR site. Then the sensitivity will become comparable to view radar. That means 10 times bigger than the existing radar system. Then we can cover the entire height range of the over equatorial atmosphere. We have already finished the design, and this antenna element will have more than 1,000 elements, and the peak power is about 500 kilowatts. But the efficiency becomes better, so the sensitivity becomes similar to the view. It's a more practical plan. We'll have radar north about a few hundred meters north of the existing system. Equatorial atmosphere radar is a powerful tool, but it's not the single one. We have a variety of observation equipment installed for Taban. So now the EAR site is the integrated observation site of various things. As I mentioned, dynamics is important, but also the chemical process is important. So by combining all these, we can get the dynamic or chemical features of the equatorial atmosphere. Equatorial atmosphere radar site is integrated site, but a single point. So in order to understand a global picture, we need to have a network of observation sites. Within Indonesia, we have 4 additional sites, Pontianak, Biak, Jakarta, Medan, also. But in addition, India, China, Australia, and Pacific, we have a network of observation. We are continuing international cooperation with it. So by combining all these various equipment, we can cover entire height range and the various parameters. Now, we want to effectively utilize these data sets. For example, we archive radar database in Japan, and another group, for example, another group of Kyoto University geomagnetic data set, and another group also archive the solar activity data set. All are distributed in each organization, but we construct the metadata system, I mean catalog of all database, and we circulate all these metadatabases to all participating institutes. Then, for example, one can check, for example, one event occurred on some day. Then, with this metadata, what kind of data available for this comparison study. So then you can try to access the data set. And by combining all these, we can start a correlative analysis of the data. So this system is called Inter-University Humanosphere Global Observation Network, UGONet. So please try to remember this word, UGONet. And if you type in Google this word, you can quite easily access the metadata. So the purpose is we have various kind of huge amount of data, but spread over institute and university. They are not effectively used. So we created the metadata set based or cross search for these distribution data. Then we can promote a new types of atmosphere research by analyzing multidisciplinary data. If one observes, for example, one launch radiosonde, one wants to use just radiosonde only. But by using this one, in addition to your own data set, you can get more additional data set for a more deeper study. Again, please remember this. And I just talked to Harim. In addition to metadata, we want to give a copy of our all data set to you. And then you can more quickly access our data set. And your data set, most of data is collected here in Indonesia. Okay, to summarize, this is a brief history of collaboration between RISH and Japan. We first installed the big radar in Japan, 1984. And 2 years after that, I made my first visit to Japan, 1986, nearly 30 years ago. And we visited Pontianak and Biak. And we continued the survey for equatorial radar site, Pontianak with Sumatra. And we tested the experiment by using radiosonde. And we constructed a small radar, meteor wing radar, boundary radar into space. And the solar campaign will continue. In 2001, we constructed equatorial atmosphere radar. And campaign continued. And we now propose construction of equatorial view radar, EMU. And we obtained I23 milestone for the radar system. In addition to research, we are also contributing education and outreach activities. It's a little old, this statistics is a bit old, but the master and PhD degree student. And also, we are continuing outreach and capacity building programs like school and OJT on the chemical plane. And actually, this HSS and the ISSH is one of these activities in order to enhance the interaction between Japanese, Indonesian, Asian, and also international community. We want to continue this activity. This final slide. I think collaboration between Japan and Indonesia is going well, and we want to continue this good collaboration in the future. And about the data set, we want to exchange the data through this system, so it's open to anyone. So please effectively use to your research. And the future key research subject is the equatorial fountain processing. Indonesia is very unique around the world, and you have a privilege to study your own atmosphere here. And equatorial view radar project is a big project. It costs nearly $50 million US or so. And this project was selected one of the 200 top research subjects by Japan Science Council. And the Japan Science Council selected among 227 top projects. We are selected again. And finally, Ministry of Education, by considering funding, they have selected 10 top projects. And we are again selected. So we are just waiting for our government funding come to this project. Okay, thank you very much.
Thank you, Professor Suda, for the lecture. And now is question session. If you have any question, please raise your hand and mention your name and your institution. Okay.
Thank you very much. Nice presentation, Professor. I don't know, I have little know about your present, but I have a question like, if there's tendency more El Nino coming this last year or maybe next coming year, what's the impact on the, like, on what is it called, plasma fountain? Is there any feedback from about for the events? Thank you, Professor.
Yeah, as I mentioned that we are talking about coupling process. Coupling means the different height range are affecting each other. So maybe this one. El Nino is the event here, originates from the sea surface temperature. So it's limited over the surface. But because of low sea surface temperature or high surface temperature, generation of convection becomes different. So that means the emission of energy from the ground up to here is affected by El Nino. Then, as I mentioned, this disturbance is not limited here. Then, atmospheric waves disturbance oscillation are generated because of convection. Then it carries energy up into the 100, 200 kilometers. And this wave, each one is very small energy, but the accumulated effect is very large to drive entire atmospheric generation. And also affect the produce ionospheric irregularity. So we cannot directly sense such kind of relation, but the detailed research clarify El Nino or any kind of disturbance over the equatorial region that affect the entire. So this is a core and the kind of heat engine of the entire atmospheric generation cycle.
Okay. For the next question. Is there any question? Okay.
Okay, thank you for the opportunity. Professor Professor Suda, I want to ask what is the advantage or the specialty of the EMU compared with the EAR? And what are the output parameter which resulted by the EMU? Okay, thank you.
Maybe output may be similar, but the EAR is a kind of a simplified system. It can steer antenna beam freely. It's the same for the mu radar. But for the mu radar, we have 25 small receiver channels. That means we can apply the quite advanced interferometry technique. That can be installed for EMU. And of course, the power is 10 times bigger. So at the moment, ER can measure up to, I think, around just below the top of important high plane, one of the important high plane here, tropopoles. Over the equator, it's located around 17 kilometers. And the current radar can measure just below around here. And the EMU can measure up to here, crossing the tropopole. And as I mentioned, for the transport of the material, water vapor, or ozone, these materials go through tropopole here or come down. So the monitoring this type range, wind velocity, turbulence, and temperature is very important. And we'll expand more about understanding what the transport is of manifestation. And that affects, for example, one famous story is the ozone hole. Ozone hole is the phenomenon in Antarctica, but it originated here. Some material was uplifted here, and the transport is vital, and eventually it reached to the polar region, Antarctica, and they produce ozone hole. So, as I said, this is a fountain, origin of the fountain, so we need to keep monitoring this item.
Okay, the data can be accessed in EUGONet. The data can be accessed. Okay, thank you, Professor Suda. Sorry, I forgot to say my name is Saila from Department of Geophysics and Meteorology, Bogor Agricultural University. Thank you.
Yeah, please really use EUGONet. EUGONet is basically the metadata system, metadata catalog. Yeah, but as far as at least our data set from reach side, all the data is open. So the beyond the data catalog, you can access the physical data set. Please use for your research.
Okay, maybe one more question for the last. No one? Okay, thank you, Professor Suda. Please give a big round of applause for Professor Suda. And now, ladies and gentlemen, we have come to the end of lecture session. Thank you to all lecturers for the interesting lectures and discussion. Distinguished participants, before we move to the next session, we would like to invite all of you to have coffee break that already prepared in front of the room. We will start the next session at 3:20.
The next session is product presentations. For those of you who are going to be presenters or would like to attend product presentations in Room A, which is here in the auditorium, is for the field of atmospheric science. Room B, which is in second floor up here, is for the field of biosphere science or geospheric science and community-based development and socio-economic science. Room C, also in second floor up here, is for general forestry field. You can move to the meeting room in accordance to your field of interest as have been mentioned earlier. Remind for oral presenter session 1 and 2. Please make sure you have submitted your presentation slide to the committee. Thank you very much.
open classification. Baru is for small, maybe local, like regional. I don't know, other to Jakarta, or I think my experience. Yeah, yeah. When dia launch many consideration, yeah, yeah. Not them, not navigation. Yeah. So it's make other with track air that is the frequency of the weather quite every and then this big bunch. Plastic. I just okay. Yes. So yeah, because the thing is around 40, 80 kilograms. 80 kilograms. 80. Yeah, 80. Man, they like a man. Yeah. So you say not classic, not using classic. Yeah, yeah. Yeah. So the authority not from so handle to Makassar region. So according to that, di Padang itu tambah ada may yeah small very small yeah 1 kilogram yeah 100 yeah yeah yes so the question was the answer yeah so we have to discuss dealing with this or facing you and yeah we because we launch depending on the weather conditions so we need more schedule and actually navigation one exact time they want to extend that our because we launch balloon depend on if 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 we if we can get more exact planning when the balloon will come out, it's more easier. It should not make much long constraint. Yes, yes, but I will. Yeah, yeah, but I will the regulation. Launch balloon, we have to. Yeah. Mhm. Small, yeah. Yeah, but no, what the cost also we have to look at it. Yeah. We have to talk about this. Mhm. So, Yeah, yeah, I know. But our experience, not about quality, was not, they want exact. They want exact timing. They they want exact time. Actually, a lot of negotiation because our launch depends on the weather. So sometimes the range, the duration is yeah. But the balance is required 2 hours. Yeah, 2 hours. 2 hours. But not up here. They, we have informed trajectory. And of course, yeah. Yeah, yeah, yeah.
幼稚な
That's
質
why
問だ。
inform
なんで熱帯の木ってまっすぐ
prediction of the no
なんか話し合ってなんかまっすぐ立つの
trajectory possibility.
針葉樹が少ないっていうのは、針葉樹だから、
だからって
まずそれは、
針葉樹は素直。
針葉樹がそのまず傾向があるじゃないですか。大体の。
でも日本の木見てもまあなんかこういうの問題はまっすぐ立ってるじゃん。
いや、結構でも、
そうじゃない。でもその辺の木って根元からまずやるとこがある。でもなんか理由があるね、その方が。
いや、多分その方が生き残るよかったからっていうのはいいんですけど、じゃあなんでよかったかっていうふうに聞かれると、
結果論。
結果論ですね。今の考えることで、
Yeah, yeah, yeah.
スマトライトの50メートルぐらいの木がずっと立ってるの見ない。ここは持ってないけど、確かに。
横に広がるのが、っていうのが太陽光源がそうそれはある。そのために根元からこう分かれてるのが上の方でわーって分かれたり。
木の種類によっていろいろ
違いますね。痩せた土に生えてる木はあんまりそんなに気にしないんですけど、ですね。だから、痩せた土に生えてるのは光がそんなに溜まってる強くないと生きていけない。だから、
分かれてもね、基本的には上に立つじゃない。これやっぱ重力を使ってる。
そうですね。
重力と太陽のあたりが。
そうですね。上に上には違う。
But this is on the
宇宙ステーションミッションというのが今度やらせてインドネシアで空港をつけて、で JAXA がやりだったんだけど、なんかね、バナナを持ってて、バナナを中国から出てきて、どう使ってやる
まあ、時々やって
やってると思う。
そういうバナナを知らないですけど、ちょっとそれで、まあ、それは甘くなったり甘くなったり。
実がなるよりも、その木の育ち方という重力がなくて、どういう
やってるはずですけどね。味のある方がね、こうっていうのが
キングがどういうかっていうのは聞けたら、そうやって育てて結構、まあ、スペースステーションでやっぱり1年ぐらいこう、そうするようになったから、結構やったんですね。
何年かやらないといけない時期だから。しかも
でも、それだってなんか
いまだにその辺はいろんなこと言ってる人がいるので、多分これだろうっていう感じなんだけど、みんなが見つける納得すればっていうと、そうでもない。
Yes.
So,
Yeah.
that's okay.
Yeah, we have to talk with this.
Do you know anyone else who talk about it?
But also,
So please ask.
I don't.
You need a speaker. There are several speaker box outside. like they are already double. But speak by itself.
How many hours? Yeah.
Yeah.
Maybe. I don't know.
So
But I forget.
one box contains two. The box
Yeah.
size dimension of the box. It is
Yes.
also how it is.
Yes.
The makeup box. They use the JBL. Then I think amplifiers. They are sold within the building. So actually they are not done. So by using that we can make a sound. Then observation parameters are very old, but they are high. So there are two sets. One is to make the box and the find the observation parameters. Then you can start the
Like they have the job.
what kind of information?
Yeah, that's right. We cannot say. Yeah. There are class. Push. Totally push for
Have you ever analyzed that? Have you analyzed that?
Yeah.
You analyze it.
When I
Okay. So
That's
very
for
good.
medium
Then
class.
you know how to analyze. Then the observation parameter, you can find when that
They mimic.
then
They mimic the
use the same parameter.
because they know the location. So
But you
if
need
there
to
is
find
a
a
coaching,
patching type. You have to apply.
app control will say pilot place do not approach because they know. And
But when you analyze, but you don't know the
maybe
because
inform the pilot that at this moment there is a balloon, so we have to
have to explore more.
it's one is there are three categories of program, but we have to discuss this. We have to make sure.
I innovated
Because before that, pertama not come.
you have USB.
This is the start, so we have experience by this experience. So
I can
the
give you
next
one
will be
example.
quite easy. Okay. Yeah, that will be easy for in the right side, the radiation control is not going to okay. Yeah, yeah. But data, we can go to yeah. Maybe from I don't know, maybe in the meeting, that's why maybe important of especially
This is actually a lecture
Yeah.
that I gave in China
yeah.
about
But also maybe our balance is
so I can give you this PowerPoint.
maybe
Also, I have
but we have to make sure
document
yeah, but we get at least
lecture note about the
I think now we can skip FRP. After FRP finish, I think we'll have the discussion. Yeah. Yeah, yes, that's right. In parallel. Yeah, like maybe we need to just schedule, yeah, something like that.
Also, for small
Mhm.
if you for a week, first start, Saturday for that, so the revision for control.
Yeah. So we can share. It's like
And also, we share information.
Mhm. Yeah.
What they want.
Yeah. Yeah, that's important.
But still, technically, that's more beautiful.
Yeah.
But I need to get what what something from some stuff. But not me, like
Yeah.
for each room, like one, two, three. That's why
Yeah, we have to just like that.
yes, yeah, then you must have become need to ask the staff become more. Then we
Yeah.
in the direct to be here. See the difference. Then maybe when I hope like we do
Yeah. 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 We are kind of thinking about daily, about like the additional days. Okay. Yeah, when they so one until 15 or 15 is the day, and then 2 days before we are and then one day if Bandung, and then one day of the if one day more, Bangkok and Bandung. So I think it's 4 days. 2 days for FRP.
different day in
Yeah, yeah, and FRP kita.
different in the Bandung.
No, 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 no coffee, no coffee. Because Vincent and yeah, Vincent are touristic. Because yeah, it's sure, but together with Lakan, really takes to the tourists. Maybe yeah, yeah, conservative. Maybe tourists. Maybe one day, but because 2 days. Then maybe night, second night,
Yeah, it's cool.
Bandung, and the day discuss. Kosong.
Yeah, yeah. Yeah. No, no. That's one issue.
Bawa laptop saya bisa. So maybe three, maybe possible, but quite dangerous. one day after. So if it's spare time, yeah, you can go. So three or 4 days. Mhm. Mhm. Yeah. Yeah.
So this is the PowerPoint that
Yeah.
include some of
But this day recommendation letter.
but it's a bit
Make sure about this. I would like to 4 days before campaign. Yeah, 4 days before. Yeah, yeah.
design of a hospital. So,
Yeah, I think better if we work on the same. Yeah, 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 yeah. I don't want one for the administration.
original shape is like this.
Yes. Yeah.
So this is idea.
Yeah.
This idea. But it becomes more tall.
Yeah.
So we fold.
Only last night
The problem is the day is when Peter is going
To start.
open say
Yeah. You have to put the speaker here. The speaker.
study or 129
Then on the counter.
we should keep that.
But we already made 10 speaker box in Kokomo.
Yeah,
But
then
yeah,
we need to talk
it's already broke.
Yes.
So we are going to make
to
a
answer
box
not that in a way.
again.
The idea you can
I think the previous speaker is already come here.
Concern about this consideration.
Not really too much.
Or
And the control system is very simple. And sound source is
directly
for
4 days before and 2 days after.
So, 2 days after, will be depending on you.
some of the example.
Yeah,
They
but
may,
maybe,
they may be closing the experiment earlier.
yeah.
This is on fire.
Also,
After the experiment,
Yeah, yeah.
there's no.
Yeah, yeah.
But
Before, the beginning gets important for parallel process.
we
Yeah. Yeah. Yes.
Some ingredients are
making the
but some ingredients are very complicated. But you don't need
Yeah.
to worry so much about it.
Yes, yes.
This is the area you use in
Yeah.
plastic.
okay. Then the commission is that day one, day one,
But
Rapansa and Richard,
Yeah. We are together. Yes, yes.
they will finish the butter. Day three is one. Day four move to
Yeah. Possibly like that. Possibly. But maybe day one, because you know, FRP process, in the FRP procedure, the scientist first run the scientist, and then they or he should come to many office that can handle with local localities. think we have to. Yeah.
When they this preparation is the office work. So it is a daytime work.
Monday.
So, kung sa naman mag-20